Name is Ginnela Someswara Sai Prasad. In this video, I will cover power density spectrum PSD or PDS auto correlation function ACF. So basic key concepts and etc. and formulas are covered in this. So let's go. What is power density spectrum? So here it shows the signal power spread over the frequencies. So how the power is spread around the frequencies means the magnitude indicates how much components it have, etc. applied to power signals. So the PDS is applied to only power signals. So for this we get the power spread over frequency how it is like that. Derive using Fourier transforms of autocorrelation. So it is derived from Fourier transforms of autocorrelation. So that's it. Meaning in simple. So you will never forget about that. That like show the signal strength lies in the frequency. So strength, the frequency strength in the signal PSD. That's it. Like checking which notes are loud in the music. So if you observe the music notes, the frequencies are increase, decrease. That is frequency spectrum. In the frequency spectrum, you will observe that which note means which the band of frequencies, how the magnitude is increase or decrease or how much it is. So it's indicate the power density, how it value and magnitude. So PDS formula. PDS is excess of omega. Why we use omega? In this omega is frequency. Omega is equal to 2 pi f. Means the f is frequency. So s xx of omega. Means where xx represents the autocorrelation or correlation or etc. The correlation used in this. So is equal to xx of omega equal to integration rxx of tau e power minus j omega tau d tau. So if you observe this equation, the Fourier domain analysis is came by into autocorrelation. So how can you say that e power minus j omega tau d tau is there? So you understand that Fourier domain analysis means Fourier transforms. So that's it. So properties of PDS. Here what is properties? Means it's how its properties and how it behaves in the frequencies etc. Let's go. Always real and non-negative means the PDS values are real, not imaginary, not complex here I not came. Non-negative means the PDS is only in positive side or plus or etc. Even function. So even function means the if you minus omega put the sxx of omega came means the minus we place the signal or the frequency is not changed, its frequency is not changed, then even function area under cover is equal to total power. So you observe that the area under cover curve means the frequency is offset the area under that this total power. How it say the total power is calculated x of integration. In this integration you will observe that integration means summation, the all summation of powers the frequency, how the power is there. So it came total power. So that's it. Definition: PDS is limit limit t tends to infinity 1 by t x of t x omega mod square, where xt is equal to integration minus t to t x of t e power j omega t. So you will observe that again the Fourier transform of signal. So x of t become xt of omega when e power minus j omega came. So again properties in mathematical representation, this xx of omega greater than or equal to 0 means it's non-negative and real numbers. Even function xx of omega is equal to xxx of minus omega, the total power. So you will see in this total power p is equal to 1 by 2 pi minus infinity to infinity xx of omega d omega. So we can find power by summating all the frequencies present in this band. So more properties like show frequency components. We use the PDS to indicate how the frequencies components are there, how strong frequency there means in this by observing that graph or like anything like phase we represents the how much it contributes. So the strongest frequency covers and etc. So what is autocorrelation? So PDS is complete. So now what is autocorrelation? Autocorrelation means the function of signal with itself. So I again repeat, autocorrelation. The signal itself is compared or change is autocorrelation, where tau is a shifting property, how much it shifts. So mathematical representation Rxx of tau is equal to integration x of t into x of t plus tau d tau. So that's it. For energy, Rxx of tau is equal to minus infinity to infinity x of t x conjugate of t minus tau dt. At t is equal to 0 means the shifting property is 0 when Rxx of 0 is equal to Ex means energy we can find. How? The minus infinity to infinity mod x of t whole square dt. So x of t into x conjugate of t become modulus of x of t. So that's its properties. So it is also even function. Rxx of tau is equal to Rxx of minus tau. So that's it. Meaning, so it's in simple and in non-technical terms we can tell that the signal matches itself, how it's shifting, like comparing two versions of sound. So that same signal is compared like that. Importance of ACF properties. It is a even function, already say maximum at t is equal to t naught t is a tau is equal to 0. ACF is equal is PDS or Fourier transforms pair. So ACF and PDS are Fourier transform pairs. So let's go. For energy signals, X already say that it is even function and it's a property at 0 it came. So relation PDS is ACF are relations. So how can we relate this? So in mathematical representation, xxx of omega is equal to Fourier transform of Rxx of tau. So you see that Rxx of tau Fourier transforms. We observe that Rx of e power minus j omega tau d tau. So that part, exponential part, converting Rx of tau into xxx of omega. So that's it. How we can find Rx of tau? The inverse Fourier transform of sxx of omega. How can we say that? These are Fourier transform pairs. That's it. So it's came. So the mathematical representation, we can see that PDS as a Fourier transform sxx of omega I minus infinity infinity Rxx of tau e power j omega tau d tau. That in this below you can see that inverse Fourier transform. In simple meaning, relationship. It tells time domain similarity, spectrum tells frequency domain power. Both carry same information, just different forms. So you observe spectrum, Fourier domain power in this. Autocorrelation is time domain. It means x of t it came. So let's go. In this how it is important in communication, we use it for noise analysis, use it for design filters, etc etc. It brings bandwidth calculation, anything. Examples of this is applications, wireless communication, signal processing, radar and images analysis. I see this example diagram where for time domain is converted into autocorrelation function ACF. This ACF by Fourier transform we get PDS. So that's it. Summary. We came to summary. The PDS is power versus frequency. So in this PDS you observe that power versus frequency. How frequency is distributed. In ACF, similarity versus time shift. How the two signals are similar. In time shift means either left side or right side. That's it. There are Fourier transform pairs. What are Fourier transform pairs? Xxx of omega and Rxx of omega are Fourier transforms. So we can find one, we have one, and we can find any other Rxs of omega. So that's it. This I will close the video. Thank you for watching. If you have any doubts, please comment on the comment section. I will explain. Thank you. Bye bye.